Greetings and welcome to SpaceWeek Live, episode 124 on this Sunday, July 17th, 2022. Sorry for the late start. I had a lot of ducks to put in a row. There's a lot that happened in the past week, and I had to get all that queued up and ready for you. So thank you for bearing with me, and welcome. As always, if you have any questions, please make sure to tag my name in the chat by typing @rawspace, so that I'm sure to see them. So, let's see. Getting to the events of the past week. Last Sunday, SpaceX launched the first batch of Starlink satellites into a new orbital shell at an inclination of 97.6 degrees from perpetually foggy Vandenberg Space Force Base in California.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of the Falcon 9 and Starlink.
Pitching downrange. Stage 1, chamber pressure is nominal.
Having some microphone boom issues here. I love that shot of the rocket lifting off over the endless cloud, the fog bank. But let's see, the drone ship landing footage was pretty choppy, but the booster did land okay.
Stage 1 landing burn. Stage 2 terminal guidance. Stage 1 landing leg deploy. Stage 1 landing confirmed.
All right, as you saw there briefly, as the smoke clears, there we see once again Falcon 9.
On Monday, a Canadian-made Black Brant 9 suborbital sounding rocket launched from Equatorial Launch Australia's Arnhem Space Centre in northern Australia. You see that here. Carrying NASA's dual-channel extreme ultraviolet continuum experiment, or DUCE, up to an altitude of a few hundred kilometers to study the Alpha Centauri system in the extreme ultraviolet light spectrum. There was some lag during the launch footage from this remote location, but the solid-fueled sounding rockets blast off so quickly, even in ideal streaming circumstances, you can barely see anything anyway. There's basically just an explosion of thrust and the rocket is gone. So here you go.
And we will follow it as quickly as we can. But, you know, this rocket moves in a hurry. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And it's going. Woo! Yeah, man, this thing moves so fast. Go, go. Yeah, do it.
That guy is very passionate about his job. Bravo to him. So the launch was successful, and congrats to Equatorial Launch Australia in either the first or one of the first commercial launches from that continent. Not an orbital launch, but a suborbital space launch in any case. Then on Tuesday, NASA made their big announcement, the much-anticipated worldwide release of the James Webb Space Telescope's first images. Well, I should say, the much-anticipated worldwide release of the James Webb Space Telescope's first scientific images and data. And it did not disappoint. Let me get that ready for you here. So, if I seem a little scattered, I do apologize. It's because I'm actually experiencing a lot of anxiety today, and so I've got the jitters, and I'm trying to focus while suppressing the jitters, and it's doing a number on me. So Because JWST operates primarily in the infrared up to about the color orange, much of what it sees is outside the visual spectrum that human eyes can perceive. So in order for us to see what Webb sees, they have to shift the color spectrum up into the visual range. The result is spectacular. So what we are seeing here, is Webb's first deep field image. This image was captured with just 12 hours of exposure versus the Hubble telescope's 2 weeks of exposure for a far inferior image of the same region. And so what we're seeing here are, if we can zoom in, foreground stars, which are these bright points with the lens flare on them, or the hexagonal starburst on them. A lot of more distant stars and galaxies galore. We see galaxies that appear to be warped due to gravitational lensing all over the place, especially right around this area. So if you're not familiar, which would be surprising, but if you are by chance not familiar with gravitational lensing, it's an effect that was predicted by Einstein and then demonstrated years later. But what happens is when there is a strong gravitational field out there in space, such as a large star or a galaxy or even a galactic cluster, the gravity actually takes the light from behind it, from our perspective, warps that light around the galaxy, around the gravitational center, and then projects that light in a circle around the gravitational source. So what we're seeing here around the periphery of this sort of this kind of circle, imaginary circle you can draw, is the projection of more distant galaxies in a virtual space around the gravitational center. It's a very strange concept to wrap your head around, and the mathematics of it are far beyond my capacity to understand, but nonetheless, it is a real gravitational effect. It's not an optical effect, it's a gravitational effect on the photons. But in any case, it lets us see even farther than we normally would be able to, because the images of the distant galaxies are basically blown up. They're enhanced. And I think, unless I'm getting the wrong ones here, I think that these two on the left are actually the same galaxy. Like these two arc smudges are multiple projections of the same galaxy. I know that one of these was listed as, or was determined to be multiple projections of the same object. And if we look in the very far distance, these fuzzy red things, such as this right here, are the most distant objects that we have ever seen, that our species has ever seen. This, as an example, this red smudge here is an example of a galaxy up to about 13.1 billion light years away, which is approaching the limit of what James Webb is able to see. Now, this particular shot kind of reminds me of the pale blue dot image taken by the Voyager spacecraft of the Earth, which occupied a portion of a pixel trapped in a sunbeam from the glare from the sun. So this here is a glare from this nearby or closer bright star. Now, if my understanding is correct, this field of view is equivalent to if you were to hold a grain of sand at arm's length. That is the area of sky that we're looking at right here. So just absolutely incredible. Moving on to the next image. Here we have some scientific data rather than a photograph, but this is data gathered of the by doing spectroscopic analysis of the light of a distant star passing through one of its planets, WASP 96b, exhibiting the telltale signs of water, H2O, in that planet's atmosphere. And so we see here the best fit model, which is, according to my understanding, what they were expecting to find in terms of the signature of the spectral signature of water molecules in the atmosphere. And these data points, and I presume that the candlesticks, the up and down lines represent margins of error, perhaps. But the candlesticks, which follow right along their best fit model, are indicative that there is definitely water in this planet's atmosphere. Now, I believe this is, I believe, if I recall correctly, that this planet is a larger than Earth, maybe 2 times the mass of Earth. But yeah, very cool stuff. The third photo they released was the Southern Ring Nebula. So this target is visible from the southern hemisphere, and so we wouldn't necessarily be that familiar with it here in the northern hemisphere. But I queued up the full-sized image, so we should be able to zoom in a lot. And so at the center we have this is a planetary nebula. So this is a star that basically ran out of hydrogen and started fusing helium, and it basically sloughed off. This isn't a supernova. This is the result of a basically its gravity. Its mass was reduced to the point where it could no longer hold onto its atmosphere, and so it threw off its outer atmosphere, which is the nebula that we see. And what remains is a white dwarf, which is what we expect to happen with our own sun in a billion or a few billion years. And so let's see how far. Let's zoom at 100%. So this is at 100%. If I zoom in any farther, it'll just be artifacts. Some absolutely stunning images. And there is a scientific explanation for why this center is blue and why it gets progressively more red as you move outward from the center. I don't have that information on the tip of my tongue, but I believe it has to do with the degree to which the atoms are being excited by radiation. And because there is going to be more, they are going to be more irradiated toward the center, they emit photons in a different part of the spectrum, in a higher frequency range of the electromagnetic spectrum. Moving on to the next image, the fourth image that NASA released. This is called Stephan's Quintet. And so we have 1, 2, 3, and then 4, 5 galaxies all interacting here. I believe this is also visible from the southern hemisphere. This is like screenshot central. I mean, wallpaper central. Okay, so let's zoom into 100%. So over here, this galaxy, we actually see the individual points of thousands of stars here, which is incredible. This must be in the foreground, is what I would say, because if it were further distant rather, then we would not be seeing these individual points of light. But and then up here we have this grand spiral with some really interesting galactic arm activity going on, almost like the arms are broken. So we see sort of a grand sweep of white galactic arm on the top and the bottom, but then sort of this nebulous stuff in between is just chaotic. And down here we have this pair of galaxies which are merging in very dramatic fashion. And finally, the fifth photo, and by far the most colorful. This is called Cosmic Cliffs. This is a detail shot from within the Carina Nebula. And this image is actually, if I recall correctly, about 14,000 pixels wide if you download the full version. And so if we zoom in here to 100%, we can see and they call them cosmic cliffs because there's such a sharp edge between the reddish orange portion of the nebula and the bluish portion up above here. And so the reason why there is such a sharp edge is because this material, this reddish orange, I mean, the material itself isn't reddish orange, but those are that's the wavelength of the photons that are being released by being blasted with radiation. So the reason why there is a sharp edge is because this is basically that edge is being compressed by radiation pressure from the source of the nebula, like, you know, so this is a planetary nebula, I believe, and the radiation pressure from that star at the center is pushing the material up against each other in such a way that we have these sharp and amazing lines of nebula, like orange nebula versus blue wispy material. But absolutely fantastic. Now this celestial object has certainly been photographed before, but at much less quality, like much lesser quality. Hubble has has photographed this. Ground-based telescopes have photographed this, but never in any kind of detail like we're seeing here. This is just fantastic. Okay, so NASA published not only the images that we just saw, but also some further analysis of those images to their Flickr page. If you, what's it called? NASA Webb Telescope, I think, is the Flickr page. And I can show you those here. So this here is another view of the Carina Nebula, those cosmic cliffs. This is a combined view from Webb's NIRCam and MIRI in the near infrared. So looking at a slightly different color frequency range, and we're able to see sort of through the dust and through the material to the stars beyond. And that's one of the great benefits of viewing in the infrared range of the electromagnetic spectrum, is that we're able to cut through a lot of that dust to see what's beyond. which is why Webb will be an invaluable tool in looking at our own galactic center, because, of course, the center of the Milky Way is on the other side of 20,000 light years of dust and gas. And here we have another view of Stephan's quintet, taken by Webb's MIRI instrument. And so you see a lot of the sort of aesthetic qualities, like the aesthetic coloration is gone, but here we're able to kind of peer through some of those colors into what lies beyond. And so, do you remember those broken arms I was talking about earlier that looked like nebula in the upper central galaxy here? We can see those in kind of in a bluish white color. And finally, the Southern Ring Nebula. On the left is NIRCam in the near infrared. That's NIRCam. And on the right is MIRI, MIRI, in the mid-infrared, which is a lower frequency, a longer wavelength of light. And we can see there in the center the binary stars at the heart of that nebula. So, back here on Earth, also on Tuesday, the very same day, a Long March 3 launched the Tianlian 203 data relay satellite from Xichang in southwest China.
点火。
Then on Wednesday, a Rocket Lab Electron launched NROL-162 for the National Reconnaissance Office of the United States in a mission called WISE 1 Looks Ahead. Their aim is to do 2 back-to-back launches for the NRO, just 10 days apart.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Being a night launch, we didn't get to see the majestic North Island of New Zealand receding into the background from the rocket cam view, but was a successful launch. And we also didn't get to see the payload deployment because it was a NRO launch, but maybe next time. Also on Wednesday, the European Space Agency, not Arianespace, conducted the very first launch of the Vega C, a larger version of the Vega rocket. It has 2 solid-fueled stages and a liquid-fueled third stage. It lifted off from the Guiana Space Center in South America, the world's most equatorial spaceport.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P120 et décollage.
the very first Vega C on her inaugural flight, clearing the mast, like you said, in a blink of an eye.
Trajectoire nominale.
Just see it through the cloud. Oh, it's a technology high on the leading edge of life there.
Pilotage
Said it was going to
calme.
be quick, Dante, and you are not joking. It's like George Russell in a racing car.
Trajectoire nominale.
From the beach in Kourou, yes, look indeed how fast it is. The acceleration is
Some animated commentation there. Commentation? Commentary. Commenting. So, yeah, again, perfectly successful mission, which is good because Vega has experienced a number of unfortunate mishaps in the past few years with a couple of rocket failures in a couple of different stages. But this launch went off completely without a hitch, and it performed beautifully. So congratulations to the ESA and to all manufacturers involved with the Vega C. Uh-oh. Let me find the launch here. So I got everything almost queued up perfectly. Okay, here we go. On Thursday, SpaceX launched a Dragon 2 Carlo, a Dragon 2 cargo payload designated CRS-25, bound for the ISS from historic Launch Complex 39A at Kennedy Space Center.
Go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
So because this was a sort of a co-production of SpaceX, it was a SpaceX mission for for NASA, and both NASA and SpaceX provided commentary. Unfortunately, when SpaceX does NASA launches, they basically piggyback on NASA's stream, NASA's coverage of the launch. And NASA only broadcasts in 720p. So while normally we get 4K resolution for SpaceX launches, this one was only available in 720p, which, because I, except for, because I only broadcast in 1080p for regular launches, or rather for regular streams, unless it's 4K. It's just upsampled. But in any case, that's an unfortunate aspect of whenever SpaceX collaborates with NASA on commentating a launch. But we get what we get. So, but successful launch, and then the booster landing.
So landing burn coming up shortly.
Stage 1 landing burn.
Keep an eye out on the speed on the left-hand side of your screen. That's the velocity of the first stage. We're going to see that come all the way down to 0. On the right-hand side of your screen is our drone ship. And also keep an eye out on the left-hand side of your screen for landing leg deploy.
Stage 1 landing leg deploy.
People real excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket.
Well done. And the Dragon 2 cargo spacecraft arrived at the space station about a day and a half after launch on Saturday.
And we're getting views right at the last second. Dragon contact and soft capture complete.
So the they lost the video of the approach of the spacecraft to the docking port, but they did manage to get that video back in the last few seconds. So docking successful, and well, soft capture successful, and then hard mate was then accomplished after that. So the space station now has new supplies, cargo experiments, and so on and so forth, all the usual stuff. On Friday, a Long March 2C launched SuperView Neo 201 and 202 from Taiyuan in northern China. Early this morning, in the wee hours my time, the Tianzhu 3 cargo spacecraft undocked from the Chinese space station. So we're looking at the Tianhe core module of the Chinese space station from the perspective of the departing cargo spacecraft. And that's I presume to be the Chinese robotic arm there, sticking out on the right side. Finally, just a few hours ago, SpaceX launched another batch of Starlink satellites from Cape Canaveral.
US 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff of Starlink 422.
Stage 1 chamber pressure is nominal.
Vehicle's pitching downrange.
So the weather was looking a little dicey. It was only 60% chance of go, but they did manage to find a break in the clouds. And what I want to do is check out in the shot coming up as the rocket transitions into the supersonic phase. Watch the compression wave at the nose of the rocket. Look at that shot. Amazing.
With that, the vehicle is traveling faster than the speed of sound.
All right, let's rewind that again.
Falcon 9 is supersonic.
With that, the vehicle is traveling faster than the speed of sound.
And so that sort of thing happens with jet aircraft and as well. You see that shock cone in front of the vehicle.
The vehicle is through the highest point of pressure it will feel during flight, also known as maximum dynamic pressure.
And the landing.
Call out from the teams of successful landing burn startup. Lighting just one Merlin engine in preparation for landing on our drone.
Stage 1 landing leg deploy.
Heard confirmation from the teams that the landing
Stage 1
lights have
landing is
deployed.
confirmed.
And
A little choppy, but near bullseye as usual. So that's actually it for the past week. Lots happening, or rather lots happened in the past week. Let me get this ready here. Boop. Okay. Looking further back into space history, this Wednesday will be 53 years since what some would say is the most significant technical achievement of our species, the Apollo 11 moon landing. On July 20th, 1969, at 2017 and 40 seconds UTC, humans touched down on the surface of another world, our moon, for the very first time. Astronauts Neil Armstrong and Buzz Aldrin exited the lunar module Eagle and spent 2 hours, 31 minutes, 40 seconds outside on the lunar surface. They planted a flag, took pictures and video, spoke with President Nixon, and collected 47 pounds of regolith, moon rocks and dust. Meanwhile, astronaut Mike Collins waited in lunar orbit in the Command and Service Module Columbia. Armstrong and Aldrin ascended from the lunar surface 21 hours, 37 minutes after landing, rendezvoused with Collins, and then executed their orbital departure burn to return to Earth, splashing down about 2.5 days later. There were 6 more Apollo launches, 5 of which landed on the moon. Apollo 13 famously experienced an explosion in their oxygen tank on the way to the moon and had to abort their mission. This Thursday marks the 11th anniversary of the end of the Space Shuttle program. On July 21st, 2011, the Space Shuttle Atlantis touched down for the very last time. On board were astronauts Chris Ferguson, Sandra Magnus, Rex Walheim, and Doug Hurley. Hurley went on to fly on the very next crewed spacecraft to launch from American soil 9 years later, SpaceX Crew Dragon Demonstration Mission 2, alongside Bob Behnken. Looking ahead to this week, on Thursday, July 21st at 1:13 p.m. Eastern, 17:13 UTC, SpaceX will launch Starlink 3-2 from Vandenberg. And if we advance to the next week, next Sunday, July 24th at 2:15 a.m. Eastern, 06:15 UTC, a Chinese Long March 5B, their most powerful rocket, will launch the Wentian module to the Chinese space station, also called the Tiangong space station. Wentian will become the station's second module, joining the Tianhe core module that was launched back in April 2021. The next module will be Mengtian, to be launched this October, and the Shunqian module will be launched next year. These launches take place from Wenchang Space Launch Site on Hainan Island in the far south of China, which, if we zoom in here, right there, at just 19 degrees north latitude. This tropical placement allows them to launch heavier payloads with less fuel because they can borrow more velocity from Earth's rotation. Interestingly, Wenchang is managed by the Xichang Satellite Launch Center, 1,300 kilometers or 790 miles to the northwest. Next Saturday or Sunday next Saturday or Sunday might be another Rocket Lab launch with the NROL mission called Antipodean Adventure. and this will be the second in the series of 2 back-to-back launches for the NRO. An exact time has not been published yet, though, to my knowledge, so stay tuned for that, and keep your eye on the raw space launch calendar for updates. All right. I would like to extend a heartfelt thanks to the supporters of this channel. Although YouTube yanked my channel monetization for the time being, Patreon, the merch store, and PayPal are still available for those of you who wish to contribute. Let's see. Oh yes, contribute to the Bennu Treats and Roz Adobe Creative Cloud Fund. If not, that's cool too. Your mere presence is appreciated. Make sure to click the like button, though, so YouTube knows to recommend this channel's content to other people. All right, let's get to your questions. Did the script do its thing? It did not. All right, so I'm going to have to scan the chat. I hope you tagged my name, Rawspace, because that is how I know you asked a question. All right. Marina Repan says, as I understand, images are made by James Webb cameras. Look blank to us, but scientists translate those images into something we can see. Is that right? Sort of. Because it's collecting photons of light in a range of the spectrum, most of which we cannot see. So the James Webb can collect photon data, if you will, from the mid-infrared up to about the color orange in the at the low end of the visible range of the spectrum. So if they were to show us unadjusted images from the James Webb, then they would look very red and orange, because that's the limit of the color range that it can detect. But yes, most of the range of light wavelengths that James Webb detects is outside of our visual range. Maybe a B. No, B's see in ultraviolet. What sees in infrared? I don't know. Something sees in infrared. The Predator. The Predator would be able to see it. All right. Scanning the chat for more questions. Sometimes we have a script running that collates the questions that are tagged with my name into a list that I can just look through, but the script is not running currently. So, okay, MVM Motovlog Music. Rawspace, do you think it possible that NASA will at some point turn JWST toward our solar system and take close-ups of the Moon, Mars, Jupiter, etc.? So, I doubt that they would look at the Moon, but they would, and they can't point it anywhere toward the Sun, so they wouldn't take pictures of any of the, I don't think they would be able to take any pictures of Venus or Mercury, certainly not Mercury, and I don't think they would be able to point it at Venus either. But so long as it's able to point out away from the Sun, then yes, they've already imaged Jupiter. That wasn't part of this first release of images and data, but yeah, they'll definitely be looking at solar system objects as well as deep space. But the primary focus, I would say, is the deep space objects, the deepest of space objects, because that's what the Webb telescope is designed first and foremost to do, is to see as far back in time and as distantly into the past as we can. So Rockin' Robbins 13 with a clarification on planetary nebulae. Planetary nebulae don't leave white dwarfs. They leave a star burning helium instead of hydrogen. And he also mentioned that the blue color we saw in those photographs is generally encoded oxygen-3 ions. Rockin' Robbins 13 also mentions that the Hubble image of the quintet, the Stephan's quintet, also did resolve the individual stars in the galaxy on the left, if you recall, that I mentioned. Yeah, no, I didn't assert that Hubble didn't see those dots, but the Webb image was definitely a higher resolution, higher quality. Scanning the chat. Okay, Julian Roberts. How many images have been released since the president's media event, which is when they released the first deep field image from Webb? I was going to say Hubble. It's not Hubble. And how long will the photos be put through? How long will photos be put through the NRO and the Planetary Defense Office for release to the public? Well, the James Webb images don't go through the National Reconnaissance Office or Planetary Defense. I'm assuming that was a little tongue-in-cheek there, but there may be a location where there are more recent images than the ones that they released last Monday and Tuesday, but I am not aware of that, of where those images would be located. I will look for them because I do want to see the latest and greatest from James Webb. But so their Flickr page basically had additional analysis of the same images we already saw. They didn't have any new images there on Flickr, but so the official images released were the 4 images and the 1 data analysis with the spectroscopic analysis. All right. MVM Motovlog Music says, was anyone on this chat able to watch all of these events live? Raw Space this past week may have been a record holder for most launches. I don't think so. Like, I know there have been a few really busy weeks that I have been subjected to by the launch industry, but yeah, this one was definitely a pretty busy one. Oh, all right. Talking about Brazil's equatorial location being ideal for space launches. Rockin' Robbins 13 regarding the Chinese space station. On various lists, the Chinese space station is called CSS, Chinese Space Station, Tiangong, and Tianhe. Just to clarify, Tiangong is the proper name of the Chinese space station. It is also called, correctly, Chinese Space Station, and it's also called China Space Station, which is conjugated a little weird, but that it's from a different language, so that's fine. Tianhe is the core module of the station, just like we have a Unity module and a Columbus module and a Zarya module on the International Space Station. The Chinese space station has a Tianhe module, and soon it will have a Wentian module. Rockin' Robbins 13, isn't it interesting that 3 of the 4 images released were of objects easily seen in a 13-inch telescope? Well, I think with their initial release, they wanted to show objects that were already familiar to people. Like, we have images of the Carina Nebula, we have images of the Southern Ring, we have images of Stephan's Quintet, although I wasn't personally very familiar with that prior to this. But I think they wanted to highlight the contrast in quality between the previous images of those objects and the new Webb images, and so, I mean, if they were like the deep field, deep field images, which are looking far beyond anything that you would be able to see with a ground-based telescope or with a backyard telescope, those are not going to be as eye-popping as, let's say, the Carina Nebula, which is visually astounding, although the deep field is mind-blowing when you think about the scale of everything. But so Rockin' Robbins also says, although the light gathering power is proportional to the area of the mirror, resolution is only proportional to the diameter, and JWST is about 3 times larger than the Gubble, which I presume you mean the Hubble Space Telescope. Images from JWST as well as Hubble are administered by the Space Telescope Science Institute, which hosts all of the images. So it is true that the STSCI, or STSI, depending on how you want to acronymize it, they are the administrating body who operates the James Webb. So their website would be a good place to go for images. Look at my cat in the background. That's Bennu, if you're not familiar. All right. So it looks like that is going to wrap it up for this week. Thank you all for bearing with me with the late start. I do want to mention that if you aren't already aware, SpaceWeek is also available as an audio podcast on Apple Podcasts, Amazon Music, Audible, Samsung, iHeartRadio, various others, and at spaceweek.libsyn.com. That's spaceweek.libsyn.com. Podcast. Chat. All right. Well, thank you all for coming. Keep it raw, and I'll catch you in the next live stream. And I won't disturb Bennu, because I know he'll just get up and wander away. But until next time, do take care. Bye-bye.